Уважаемых пассажиров, Aeroflot is sad to announce that Flight 61 non-stop service from Moscow Domodedovo to Sokol Magadan has been cancelled due to inclement weather in the Moscow area. I am sure Vladimir Vysotsky will write a weeping song about how he can't fly to Magadan today. Sadly, yes, the weather here today is sad, but it is a perfect opportunity for an introduction on how to prepare and fly the Tu-144D for Flight Simulator X, one of the best freeware add-ons, and possibly one of the best add-ons for Flight Simulator X ever made. And it is pertaining to a very, very interesting airframe, an aircraft that I've had a passion and interest in for a very long time, and it is lovingly recreated here in the sim by talented developers and people just as passionate about the aircraft's history and performance as I am. I am by no means an expert on the Tu-144D. I will not proclaim that I am, but I do know a thing or two, and I've had a desire for a while to share this knowledge with my dear viewers and friends so that other people can partake in the joy of flying this plane, because I am of the opinion that knowledge should be shared and not held on to. This example, CCCP 77105 aircraft 03-1, was the first Tu-144 to be re-engined from the NK-144A Kuznetsov engine to the more effective and higher fuel efficiency Kolesov RD36-51 non-afterburning turbojet engine, which allowed the Tu-144 to fulfill its range requirements as set out in the original order by the Council of Ministers of the USSR. Aircraft 77105, or 03-1, was the first to complete a non-stop flight between Moscow and Khabarovsk in the Soviet Far East, and paved the way for the development of the Tu-144D as a whole. Today, we're going to be using it as a testbed to how to prepare and fly the Tu-144D in Flight Simulator X. From the very beginning, that is flight planning, to firing up the aircraft, flying it along the route, and landing it, in this case, in Magadan. I've chosen Magadan and not Khabarovsk because I've flown to Khabarovsk before. Others have flown to Khabarovsk before, and I'd like to do something a little different. That having been said, I would like to extend special thanks to the following people. Moy Polyoty for his plethora of videos on the Tu-144D, both in English and Russian, as well as for having created the MYNL flight planning software for the Tu-144D. More on that later. Special thanks as well to Paxiod Flyer for his excellent video in Russian for Flight Simulator 2004 on the Tu-144, which will, all of these will be linked down below. Special thanks as well to Flight Instructor Online for his great article on how to set up and start the Tu-144, as well as links to downloads and the MyNL software. Again, this will be linked down below. And finally, a special thanks to Автопилот Aviation on YouTube. As far as I can tell, an inactive YouTube page nowadays, but he has a general overview on how to set up and start the Tu-144 as well. It's a very quick and dirty, quick start guide, and it was very useful as well for setting this up. Unfortunately, I don't want to go over the specifics of setting up the binds for this aircraft, the custom bind system. It's a little bit intimidating even for me now. I don't like to mess with it. But if you want to have a look at that, Autopilot Aviation's video is a perfect starting point. Now, that having been said, let's take a look at our flight plan. Like I said, Moscow to Magadan, I planned a flight using Little Navmap, one of the best softwares there are for Flight Simulator planning. I use it for Flight Simulator X, but it can also be used for Flight Simulator 2004, I think. Prepare 3D, X-Plane, Flight Sim 2020 and 2024. Really, it's just a navigational map where you can put points down and then import that into Flight Simulator flight planning system, or another piece of software like NCalc for the T154 as well. Anyway, let's take a look at our flight plan. So I have Little Nav Map up now, and we have our departure airport set as Moscow Domodedovo, uniform Delta Delta. I set our initial fix as the Kartino NDB, just to the northwest of the airport. This is using an older version of the Navaid database is not up to date to 2026 standards, so a lot of these will not be present anymore in, say, 2020 or 2024 or X-Plane 11 or 12. But in any case, we have Cartino set as our first waypoint. Then I have a waypoint immediately after our top of climb, more or less. And then I have waypoint set all along this great circle route all the way to Magadan. And I have an alternate in Yakutsk right here. So the way that I like to plan flights for the Tu-144D, I set first my departure and destination. It gives me the great circle route. I find an airport in the midway point. In this case, we have Norilsk, Kalikel, that I've set as a waypoint. And I'd like to divide the legs up into 950 to 1,000 kilometer intervals. That way you can have a good division of waypoints that you can cross-check your position in using VORs, NDBs, and such. And to also have the counter on the HSI not top out at 999, at which case you need to refer to the FMC to know your position. I also like to set up a waypoint right before the top of descent. That's about 450 kilometers, give or take. And my before last waypoint is usually an initial fix for a procedure, in this case, or a star. In this case, I have Turkey for Magadan. And the last fix is, of course, Sokol. The Tu-144's flight management computer can only handle 10 waypoints in its memory bank. And I think up to 10 airports as well. So the way I set it, I have my flight plans up to 10 waypoints, and then I set sometimes manually in the XML file an alternate airport. In this case, I set Yakutsk as my alternate. So after that's done, you have your flight plan and you put your waypoints down over VORs or NDBs or what have you. What you do is you export it as a Flight Simulator X flight plan, and then you import it to the next piece of software called MYNL. So MYNL is a proprietary piece of software made by Moy Polyoty that automatically takes your Flight Simulator X flight plan and converts it to the Tu-144's flight plan XML file. So what we want to do here is go to the bottom right where it says load flight plan. We tick off star and SID. We don't want stars or SIDs for this aircraft. We click load flight plan. We go to the flight we want to load. In this case, it's Domodedovo to Sokol. We open it. And as you can see, this is our flight plan as we put it on little nav map. It's all good. We want to go to Tu-144 here. And this is the information in this flight plan spat out as information to go onto the Tu-144's flight plan. So what we want to do now is save Tu-144 flight plan. So what we do now is we go to FSX, doc Tu-144D, and we save and replace the flight plan XML. Now, I already have this loaded up, so I'm not going to save, but this is where you load, and you do want to overwrite the flight plan XML file because that is the single file that the FMC references to set up your flight plan. So you need to overwrite it every single time you do this. In these folders here, we have pre-made flight plans for the routes that the aircraft flew in real life. We have Almaty-Domodedovo, Domodedovo-Almaty, and Domodedovo-Khabarovsk, or Khabarovsk, if you like to say it that way. So once that's done, you boot up Flight Simulator X, and now first thing that happens is Flight Instructor Online goes over this, but the aircraft wants to tip on its tail. You need to bind the controls. Your head looks up, and you can't look down. That's all covered there. I just want to focus on starting up the aircraft, going over every system, what it does, how it works, so we can go cold and dark all the way to Magadan. All that having been said, let's hop inside. So we have here the 2D panel for the aircraft. I'm going to go over every instrument in this panel, the sub-panels, and the click spots for the cockpit. Let's go over the instruments as they're laid out right now here. We have the T-zone here, the essential instruments for instrument flight. We have our attitude indicator with a flight director flags. We have our vertical speed in meters per second, our speed in kilometers an hour, and our HSI down here. To the left, we have our MAC gauge, our RMI, This is a combined angle of attack and G meter, angle of attack on the left and G meter on the right. Skin temperature gauge, which is important for cruise flight. Our cabin pressure and differential pressure gauge. Our flight controls position. So this is rudder, deflection left and right. This is elevator, deflection up and down. And this is aileron, deflection left and right. And down here is the clock, which you can bring up by left clicking it. On the right, we have the climb and descent profile gauge, which is something that we're going to go into when we're in flight. Our standby attitude indicator, our altimeter in meters, an additional vertical speed indicator. This one has a scale that goes up to 200 meters per second. This is a military style vertical speed indicator, the one that you'd fly in MiG-21s, 23s, 29s, and so on. And our radar altimeter down here. Hi, this is post-production Tony. I forgot to highlight a few instruments. So on the right side here, we have a pitch indicator. This is used for when the nose cone visor is up because the visibility outside is quite poor. So this is an additional instrument to measure pitch. And then below that, you have your RPM gauges. This is N1 only for engines 1 and 2 on the left and 3 and 4 on the right. And then you have your throttle angle position indicator, which is how you measure the power output per the climb and descent profile. This will be explained in the climb, takeoff and climb, and en route segments of the video. And then you have the annunciator lights as well on the top of the dash and on below the engine gauges there. All right, back to the video. This cockpit is actually huge. If we can look in our 3D view, it is very big, has a lot of instruments, and so the 2D panel is equally big. The 2D panel, you can fly the aircraft essentially just from the 2D panel, and a lot of the flying actually needs to be done from the 2D panel, sadly, because this version for FSX, there are more modern versions of this add-on for Prepared 3D, but I'm doing this one specifically for the FSX version. Your mileage may vary with the Prepared 3D version, but specifically, when you're getting to cruise, you need to be on the 2D panel because the 3D panel version of the skin temperature gauge does not work. In any case, let's go over the sub-panels here that the aircraft comes with. So with the shortcuts on the keyboard, Shift 1 enables and disables the overall 2D panel. Shift 2 brings your FMC up. Shift 3 brings your autopilot and nose cone position gauge. Shift 4 brings your nav radios and HSI mode panel. Shift 5 brings your binds control. We're not going to look at that today. Shift 6 brings up the flight engineer's fuel management and center of gravity control panel. Shift 7 brings you ground equipment, doors, and quick alignment help button. That's this one right down here. This allows you to go prepare the INS and align stuff and populate the FMC. We're not going to be using that today. We're going to be doing this cold and dark. These two buttons allow you to put the passenger stairs, as we can see here in the external camera, and we'll enable this panel here. And we can also operate the doors from this position. Second passenger door. The main door. And if we go to the rear of the aircraft down here, we can also open the baggage door. And in due time, a little baggage cart will come out here. That's the Shift 7 panel. Shift 8 brings up your audio control panel, your autopilot channel panel, and your transponder panel. Shift 9 brings up the pilot's overhead switches panel. That's it for keyboard shortcuts, but there are a few other panels that don't have keyboard shortcut binds that we want to take a look at. For instance, the overall overhead panel. You have a click spot around here. The co-pilot's overhead panel, right on the far right corner. The comm overhead panel can be accessed here. The pilot's overhead panel here. The autopilot panel or autopilot channels panel here. The hydraulic systems panel here. The autopilot yoke controls here. The navigational gyros and course setting panel and landing gear position indicator, as well as canard and nose cone indicator here. And if we right click, this is the INS alignment gauge here. And if we want to go to the flight engineers panel, we left click on the attitude gauge here. In the flight engineers panel, there are further mini panels that need to be brought up. The fuel controls engaged, the fuel panel power here. The engine start panel here. This in real life would be a little panel under this wooden desk here. The air start panel here. The air conditioning panel here. And the fueling panel here. So now that we're familiarized with the click spots as well in the pilot seat, let's take a look at the flight engineers panel. Top left here, we have the hydraulic system. This panel is the electrical control system. This is the APU panel and controls. These are engine parameters, so intake temperature, fuel consumption gauge, the throttle angle gauge, the N1 and N2 gauges, exhaust gas temperature gauges, intake ramp position gauges and controls, and a combined 1, 2, 3, 4 engine oil pressure or fuel pressure, oil pressure, and oil temperature gauge. On the right here is the fuel control panel. We have a clock, Mach meter, speed, and altitude, our center of gravity gauge, fuel tanks 1 and 2, fuel tank 4, fuel tank 5, fuel tank 3 and 7, fuel tank 6 and 8, total fuel on board. Right here we have the engine feed pumps, the automatic fuel balancing switch with the associated rocker panel, and a digital fuel consumption totalizer, or fuel on board / consumption digital gauge. Now that we're familiarized with the aircraft, let's go ahead and power it up by the flight engineers panel. We want to engage batteries 1, 2, 3, 4, and guard them. And we have the parking brake set. We want to ensure that we have ground power by switching this to wrap. We have 220 volts and 400 hertz. We switch ground power on, and we switch on the rectifiers 2 and 3, and we see the batteries are no longer powering the aircraft system buses. And now the aircraft has electrical power. What we want to do is switch on power to the fuel consumption and control switches, and we want to fuel up the aircraft. This is post-production Tony again. We need to talk about the fuel for the aircraft. So this is part of a Excel spreadsheet that comes with the plane called Fuel Calc, and you can input the information for your flight here and get the amount of fuel that you will need. So for instance, we have our flight here to Magadan, distance of 5,910 kilometers. We have a payload of 8.5 tons or 8,500 kilograms. Our Mach number is going to be 2. That gives us a flight time of 3 hours, 22 minutes, and a required fuel load of 91.6 tons of fuel. And now this divvies up our fuel consumption. So 2,000 kilos for taxi, 16.4 tons for climb, 57.6 tons for cruise, 5.5 tons for descent and landing, and the emergency reserve fuel of 10 tons. That gives us a takeoff weight of 197,540 kilograms and a landing weight of 117,900 kilograms. Our top of descent will be 438 kilometers from departure, and our top of descent will be 423 kilometers before our arrival airport. I usually round this up to 450. So that's how you use this. Okay, back to the video. So we can see here that our total fuel is 8.8 tons, thereabouts. So we'll load up with 86.2 85.2 tons of fuel. So we go here, right click to increase by tens, and then you can use scroll wheel to increase like that. So 85.2 tons, and we click Pusk to begin refueling. Now what we want to do as well is start aligning the INS, which is the most time-consuming aspect of powering up this aircraft. We want to right-click here, bring up the INS panel. We want to turn on the INS, включены, and we turn on the gyro heating switch. We are waiting for these two yellow lights to light up, and that tells us that the aircraft is ready to begin aligning its inertial navigation system. The yellow lights are on, and now we can switch to подготовность, or prepare. And now the INS will begin aligning. It is imperative that you do not move the aircraft while it is aligning, otherwise you will have a completely misaligned INS, and you don't want that. We can close this, and we can start doing preparations for our flight management computer as well. First things first, we'll set our reserve fuel of 10 tons. By doing that, we right click on this guard, left click, we go to the data entry panel here, we clear line 1 with this button, and we insert 100, 10 tons, 10.00 tons, and we click enter. So now our emergency fuel reserve is set. A quick overview of the FMC. On the left, we have our waypoint number, our time that we're due to arrive at the next waypoint, the distance to the next waypoint, and the time that we're going to be overflying the waypoint. We can switch between aerodrome distance and waypoint distance. We can switch between metric and imperial. And this is our programming switch. And this is our overall power switch to enable the INS to begin functioning. And this switches the times between Moscow times and Greenwich or Zulu times. On the right side is the data entry part, or data query part. And we have a first line for data entry, a second line for data entry or display. And we have different buttons here. This is our distance to the next waypoint, our delta H, or distance from the vertical profile. Unfortunately, this is not displayed in the, or not simulated in the aircraft, as far as I can tell. Neither, or this part here, I am quite uncertain of what it does. Sorry. Delta Z and delta S is our deviation from our presupposed location. It's our drift gauge, and this is coupled with the VOR corrections that we're going to be talking in a little bit. This is our current lat long of waypoints, and we can query the positions of waypoints by putting in their numbers. They go from 0, 1 to 1, 0, so 1 to 10. So waypoint 1, waypoint 2, waypoint 3, 4, 5, 6, 7, 8, 9, 10. This is our aerodrome query box, so we can query the fixes of our aerodromes, arrival or departure, arrival, and alternate, as I've put in manually. So 4.1 is your departure aerodrome, 4.2 is your arrival aerodrome, and you can have up to 9 aerodromes programmed in data blocks. So from 4.1 to 4.9, I have 4.3 set as Yakutsk right here. This is north latitude and east longitude. This is the data blocks for your navigational fixes. So 5.1 is our first navigational fix, and we can see the frequency here on this button, 1333. 5.2 is our second fix. It's also 1333. And 5.3 is our third navigational fix, which is 114.2. Down here is our wind speed and direction gauge. So here is the speed, and the direction is down here in degrees. This is the code entry window for calling up specific functions of the FMC. This is the time switch. in this case, the aircraft has been powered up for 4 minutes, so it says that the time is 0004 and 10 seconds now. And this is our VOR DME corrections button, basically. We're going to go over that in a second once the aircraft is fully powered up, because before the aircraft is powered up, this data is not displayed. We'll go over this once the INS is warmed up, because before the INS is warmed up, this data is not displayed. Let's set in the time. So right now, it is 14:49 Zulu, which means that the Moscow time is 18:49 or 6:49 p.m. So what we're going to do is the data block the time that you enter is always referenced as Moscow time. So if you want Greenwich time, you need to add 4 hours to your current Zulu time and put that into this window. So for entering data into the FMC, you use the lower panel here, the blue buttons. This is the code selector, but if you want to put in data on either one of these data blocks or these data entry and display panels, you need to either click Zbros 1 or Zbros 2. In this case, we want Zbros 1. So let me reset here. We clear line 1. It is currently 1850.50. So 1850.50. So we have 1850.50, enter. And so now this is set as our new time. It's actually 1851 now, so I'm going to go ahead and correct that. So 18511, enter. So now the time is correct. Once the INS is aligned and this is all ready to go, it'll display as Moscow time, and you switch to Greenwich and it'll display your correct Zulu time. So now that that's set up, I'm going to wait for the INS to finish aligning. It's a 30-minute process from start to finish. And once it's aligned, I'll return and show you the following steps and what you need to do to power up the aircraft and get it ready to taxi. All right, we're back here. And as we can see now, the INS has finished alignment. Over time, as the INS aligns, the attitude indicator centers to the horizon, the RMI gets put into the correct position, the HSI gets put into the correct position, everything starts coming alive in orderly fashion. So we can go ahead now and switch the INS to the Regime NK Roulenie position. And now it is operative. What we can do as well now is take a look at our INS. We can input our initial position. So I'm going to call up. You can do this via Jepson chart and what have you, but let's do it with the built-in tooltip here up top. So we're going to put in north 5524.6, which is about 40 seconds, and 3753, also about 40 seconds. So we want to do that here in our lat long gauge. This is our initial lat long. So we want to clear line 1, put in 8 for north, and then 55, 24, 40. So 55, 24, 40 seconds north, enter. Then we clear line 2. We are east, so 6, 0, 3, 7, 53, 40. So 37, 53, 40 east. And now we can see here our position has updated. And now we can start toggling the FMS to the programmed position. So we go to Echelon Program, go to PPM, PPM 1, execute. Landing aerodrome, we set it to 2. 1 is origin, 2 is landing, 3, 4, 5, 6, 7, 8, 9 are your alternates. So we go to 2 for our landing aerodrome, execute. Now we can check here distance to our landing aerodrome. That's going to be Magadan, 5,912 kilometers. Distance to our first waypoint is 21 kilometers. That checks, and it's highlighted here on the HSI. And what we can do now is start programming the automatic sequencing of the waypoints. So we go to 7.2, which is the automatic sequencing block callout. We go Zbros to clear line 1, And we want to automatically sequence between waypoints 1 and 10. So we go 0, 1 is going to be our first waypoint, and our last waypoint is 10. So 1, 0. So 0, 1, stop, 1, 0, enter. And now we're going to be automatically sequenced between waypoints 1 through 10. If it doesn't work, you can manually select which waypoint you want to go to here on this dial and press enter. What we want to do now as well is set up our corrections for the INS based on VOR DME. We're going to go ahead and now that we got ground power, we're going to go ahead and power up the aircraft. So the no smoking light, seatbelt light, the exit light, heating light for the window, I think, the temperature, skin temperature gauge, standby gyro, and assorted avionics, attitude or AOA and G meter, and we test it here. Like so, we test it on its maximum deflection, its minimum deflection, and the neutral position. We go to the co-pilot's overhead, turn on our nav light, our landing gear lights, the co-pilot side avionics, and test the oral alarm Almaza.
Проверка Алмаза.
There we go. We can also go up here, turn on our RSBN, our Course MP, and SDK, our nose wheel steering, our attitude control here, and we can test it. There we go. And now we can start setting up our VORs here. So the correction is indicated here, Smeni Canal. That means that we have the incorrect channel, or the channel for VOR INS corrections is not set up properly. So to find out what channel we need to set in, we click Voidsk, and it tells us it wants 133.3. We set it here on nav1, 133.3, and we switch the corrections panel to the VOR DME position. And the light extinguishes, and we can close this panel, which can be called up, like I said, with Shift 4. And now we are ready to get our corrections. We go to Delta Z, Delta S, and we see that we have a little correction. When there are no corrections to be done, this is going to be 0, 0. And we want to engage corrections, so we switch this to the up position, and we press enter, and the coordinates correction switch comes on. So setting up the FMC, only one thing left to go. We go to code 7001, and that tells us, that is telling the FMC to go active. We press enter and engage the FMC. Now it's going to be working from our present position, and now we can go back to the programming switch and press enter. We are done setting up the FMC. All right, and with that, we are ready to start the aircraft. So what we are going to do now is close the doors. And the lights all extinguished, they're all closed. We can remove the passenger stairs. And we can go ahead and turn on our beacon. And we can turn on our APU now. So main starter bus, starting position. When this light turns on, we have fuel pressure, and we can now start the APU. Now the APU is started. We check that it is outputting the correct voltage and frequency. It is. APU can come on the bus and turn off the ground power. And we also want APU bleed for the engine starts, as well as for pressurization on the ground for the AC. So we click and hold the switch to open the air bleed valve. This light extinguishes, and we see that the hydraulic system is beginning to pressurize as well. Fueling is accomplished. We have our fuel set here, and we can check the total sum. It is 94-ish tons of fuel. That's correct. can turn off the refueling panel here. This is important to turn off, otherwise you're just going to be refueling as you go, which you don't want. We can turn on our fuel pumps for all the different fuel tanks. So a quick word about the fuel system before we get going. The fuel system on the T-144, we have 8 tanks, but not all tanks in the aircraft feed the engines. Tanks 3, 4, 5, 6, and 7 feed the engine, but tanks 1, 2, and 8 do not. Tanks 1, 2, and 8 are for training purposes only, and we can see them here on the pop-up Shift 6 fuel control panel. This is tank 8. This is tank 6, 4, 2, 1. So tanks 1 and 2 and 8 do not feed the engines. Tanks 6 and 4 do feed the engines. So this is the panel that we want to be taking a look at to move the fuel around. And we want to make sure that the fuel is within these CG gauges here, the yellow marks. Otherwise, the aircraft will become very difficult to control. Anyway, let's turn on the air conditioning system and pressurization. So we go these switches to open, bleeds to on, and the automatic temperature control can go to automatic on all 5 switches. Set our temperature. This is not necessarily, it's not strictly necessary, but it's good practice. And now we can turn on the bleeds to the APU. So we're gonna just move some air in here and finish preparing the aircraft for startup. So the engine ramp controls can go to automatic and on. We start on the sequence 2, 3, 4, 1. So we select the fuel, oil, temperature, and pressure gauges selector to the 2 position for engine number 2. We will begin to open the fuel start panel here. Switch it to engine 2. Circuit to on. Start position. And all we need to do now is turn off the APU bleed so that we have bleed for the ends. Turn on the standby fuel starter pump for engine number 2. And the low fuel pressure light extinguishes, and we're ready to start. And so we can press Zapust. And we have the wind up. There's N2. We're waiting for N1 to reach 15%, and we introduce fuel. There's 15. Fuel. Green light. Light off. EGT. N1 is rising. Fuel light comes on here. We can switch to the main pump. Got fuel pressure, oil pressure is coming up, oil temperature is coming up. We can also set the generators, I was remiss, set the generators to the test position. And we can check generator 2 here. Generator 2 is outputting 220 volts at 400 hertz. All lights extinguished on engine number 2's panel. We can put generator 2 on the bus, and we can switch now to engine 3 and continue the process. So standby pump. Engine number 3, low pressure light goes off, switch to 3, start. Wait for 15 on the N1. Fuel, green light. Light off. EGT, N1, fuel pressure, oil pressure. Generator 3. Put on the bus, and now the APU is no longer on the bus. Starter cut out, fuel to main, lights extinguish, light extinguished, low oil pressure light extinguishes, good. Starter 3 complete, start 4, and you proceed to do this for all 4 engines. that successful start on all 4 engines, we can switch the starter panel off. All green lights here, it's all happy. We can switch the APU off the bus, close the APU bleed, and shut off the APU. And our pressurization system, the engines are already online, so the air conditioning pressurization is engaged. APU is off. We can switch off the APU. Final preparations here, we set the PO500 to automatic, the PO15000 or 1500 to automatic as well. Transformers 1 and 2 to on. No lights on the electrical panel, APU is off. No lights on the engine panel. We got positive fuel. We can also turn on the fuel balancing mode to automatic and turn on the fuel counter here. So we have 84 or 94 tons. We'll set 94 tons of fuel, and this is an electronic backup to this. We have about 93 tons, so we'll go 93.6 here. Alright, so we can go back to pilot panel here. Here we turn on our autopilot channels. All 8 of them, or all 12 of them in this case. We can turn on our hydraulics and guard the switches. And at this point, I'm going to go ahead and go to the virtual cockpit to make sure that these switches are all guarded. They are. And we can see that our flight controls are free and correct there on the gauges. Make sure all the upper switches here are on. This is guarded, on. This is guarded. Everything is on here. This can come on. Turn on our taxi light. And now we lower the nose cone. You can either do this through a specific bind or through this switch here. I have a bind, so I'm going to go lower the nose to the taxi position of 17 degrees. And we can also extend our canards. Canards extended and the nose is extended. We can check that the gear and the canards are extended here, and the nose and transit light is off, and the sound has gone off. And we have no lights here. The not ready for takeoff light is extinguished, which means the aircraft is configured for takeoff. But now for tax, we turn on our 60 degrees of nose wheel steering, and the light comes back on. That means we are effectively ready to go. However, as I had previously stated, the weather is quite inclement. Not only here in Moscow, but on the way to Magadan as well. So this was only an instructional guide for the second officer on how to, or the second pilot, excuse me, on how to start and get ready to go to fly this. It is incredibly interesting and very fun to fly aircraft. So that's it for part 1 of this video. Parts 2 and 3 should be taxi, takeoff, en route, and landing. I don't know when they're going to be ready, but I'll try to do them in the near future. And I say that knowing full well that when I've said that in the past, it's taken a long time for videos to get done. But anyway, I hope this was helpful, and I hope to see you here soon again for our flight to Magadan. Farewell.